Hello, class. So today we are going to do a thing explainer, but before you start groaning, you don't have to write your own. We're going to look at the one that's in our book. I know a few of you have had trouble accessing your book at home, so I went ahead and turned it into a PowerPoint. Here, let me move me up there so we can see it. So I'm going to read it to you and explain the directions. So it says toll roads, roads that help people walk over deep holes. You know that all structures have forces acting upon them and that forces always exist in pairs. What forces must engineers consider when designing and building bridges? So hopefully you know the answer to that as we've talked about compression forces and tension forces. As you read this explanation of how bridges are built, keep Newton's third law of motion, action, and reaction forces in mind. The story of getting from here to there. So the Earth's pull holds people to the ground. Hey, get back here. We like to walk around, but sometimes the ground goes places we don't want to go, like in a deep hole or under a river. We can't get past those places because we have to follow the ground. Birds don't, since they fly by pushing on the air. Someone in a movie once said, if birds fly over the sky, why can't I? The answer is, you are too big and you don't have wings. If you want to go somewhere, we can make a road that goes straight across high above the ground. Making short roads over holes in rivers is pretty easy, but making long ones can be very hard. Hole. Sometimes you want to walk somewhere, but you don't want to go where the ground goes. Road. If the hole is small enough, you can put a board over the hole to make a new road. Then you can walk across the board. Long road. If you find a bigger hole, you can try to find a bigger board. Bigger boards are longer and stronger, but they're also heavier, and bigger things get heavier faster than they get stronger. Longer road. All boards bend a little, and longer boards bend more. A long enough board will break under your weight, and a very long board will break under its own weight. Bendy road. You can cross a large hole with a road that is allowed to bend. If you tie many small boards together and let it hang, bending won't hurt it, and that will let it hold more weight. This kind of road gets stronger the more you let it hang down, but it also gets harder to walk across. If it hangs down too far, it's no better than just walking down into the hole. Thick road. You can cross a bigger hole if you make a board thicker. Thicker things are harder to bend, so that kind of road is stronger. Tall road. It might seem like it would make more sense to put the extra thick below the road because it's holding the road up, and we usually hold things from below. But if it's stronger mostly because it's thick, then it would work just as well if you added the thickness above the road. Road hanging under a stronger shape. Since all this stuff you're adding is just there to hold the road up, that stuff doesn't need to be near the road. You can make a strong metal piece that goes high up over the hole, which gives it a stronger shape, but would be harder to walk on if the road went that way. And then use strong metal lines to hang the road straight across under it. Hanging road problems. When you hold a road up by hanging it, you have to be very careful. These tall roads keep the road from being moved by the Earth's pull, which is always straight down. But wind can make the road swing side to side. Some roads have fallen down because the builders didn't understand wind well enough. Road hanging from sticks. Another way to hold up a road is to build very strong sticks, then hang the road from the top ends of the sticks. The line needs to be a little stronger than the lines in the other hanging road, and the sticks need to be really strong. On the other hand, there are only two sticks, so they can make building easier. This is the best kind of tall road. That's not really true. Different tall roads are good for different things. But a lot of the time, when you need to cross a big hole, this kind of shape will let your road reach farther than any other shape would. This is the best kind of tall road. Oh, that's a repeat. It's just a picture of that kind of tall road. And here's a real life picture of that kind of tall road. Tall roads on other worlds. A very bright person who is known for calling the Earth a pale blue point once said something interesting about these kinds of roads in one of his books. He pointed out that everything about the shape of very tall roads is decided by the laws of space and time, the laws that say how a world's weight pulls things, and those laws are the same everywhere. That means that if there's life on other worlds, the road shape that works best for them should be the same one that works best for us. Our tall roads may look familiar to them. Maybe that's true. Maybe it's not. We don't know if there's life on other worlds. And if there is, maybe they don't build roads at all. Maybe their way of living is different from ours in ways we can't even think about. But if they have holes they need to get across, and if in their world they'll build things out of different shapes like us, and if they have problems with holding the roads up, then they very well may build tall roads that look like ours. I like that idea because now when I look at one of these tall roads, I always feel a little happier. It makes me think about how maybe somewhere far across space and time, there's someone looking at another tall road, thinking about how the shape might be found across many worlds, and maybe wondering about me. So that story is in your textbook, but I want to remind you it is by Randall Monroe, and he has a book called Thing Explainer. It's a very fun book. So I heard a lot of you were bored. Maybe you should try reading a new book. And so here's one of my favorite books. So you might have noticed in the PowerPoint that there were questions in red. So now that I have already read it to you, your assignment is going to be just to go back and let me start from the beginning for a minute here. You obviously can pause the video, but when you look on this, it says number 1, Earth's pull equal. Because remember, the way these work is he can only use the 1,000 most common words in the English language, is how he wrote his book, The Thing Explainer. So when he talked about the Earth's pull, I want you to tell me what science word he was referring to. So either on the PowerPoint, some of you have been turned um, not on the PowerPoint because it's a video. So on a piece of paper, you'd put Earth's pull, and then the answer is he's talking about gravity. And then, we've read this page. You could reread it to make sure you're following along. But on this one, I just ask you a very simple question. What is the word for tall roads? I hope you know that word. We've only been studying it for about 3 weeks now, but it's not one of the most common 1,000 words in the English language. So you just tell me what tall road is. So continue to go through. Here's a simple picture of a bridge. I'm going to ask you what type of bridge. A few of them are in here. And if you forgot, go back to one of our previous assignments where we looked at the 7 different types of bridges. Students turned in PowerPoints with them all labeled. There's lots of information for you there. So just go through this and go through and just answer the questions as you go through the video. And so obviously you can pause it to answer another what kind of bridge is this. So if you're not sure, you can go back to those previous assignments. So I hope you have fun with the Thing Explainer. Yesterday's was a pretty long assignment, so if you haven't finished it, make sure you try to finish up yesterday's assignment on steel, because tomorrow we're going to be looking at fun concrete. All right, bye.